What's up, guys? I'm back, and I have more done. Here's the power supply. I did a unboxing for all these parts on. Well, I uploaded the video Friday night or Saturday morning, one of them. It's probably morning. It's probably like 2 o'clock in the morning, whatever. Maybe the afternoon. Yeah, the afternoon, because that video didn't upload because I turned my iPod off. But anyways, did the unboxing for that. And people keep their coils in a motor. He told me to upload more videos because he enjoys watching them. So just for you, buddy. But anyways, what we have here is a 12-volt center tapped toroidal transformer, and power input is right here, and this will just connect onto here like this, if I can. Okay, well, you get the idea. Yeah, like that. There, it clicked. All right, but anyways, fuse for the transformer. It's a 2.5 amp fuse. I just had it laying around. I thought it looked cool. I'd use it. So anyways, primaries are doubled up. Secondaries come over here. They're put in series, and one of them through black, and then red and orange connect to this one, and then black and yellow connect to this one. So this gives 6-volt power supply. This is for the 12-volt power supply. Then we have the input. The 120 input goes down to this bridge rectifier here, into this filtering cap, and then that goes through this fuse and out here. And try and provide some isolation, I drilled out the copper pads, kind of create a little line, a little barrier, I guess. I don't know. Not really sure if it's really going to be effective or not, if I even needed to do it, but I don't know, I feel better doing it, so I did it. That's about it for the power supply. Hopefully this transformer will hold up. It should give 17 volts with no load. And drawing, I only need probably about 200-300 milliamps to actually drive the MOSFETs. So hopefully it won't sag down too much. As long as it doesn't go down past 14 volts, we should be good. Or I should be good, because the regulator needs at least 14 volts to output a steady 12 volts. So we're going to set this aside here, and we'll open this up here, and we got the boards in here. This is the heatsink for the half bridge, and you can see it's all nice and pretty. Anyways, here is the unfinished half bridge. I still have to order the MOSFETs yet, but someday, eventually. Freewheeling diodes, 15 volt, 3 watt Zener diodes, 12 ohm 1 watt gate resistors with some discharging diodes. These are 1N5819 diodes, and what these do is they allow the negative pulse to bypass the resistor and go straight into the gate to kind of help slam the MOSFETs off, if you will, I guess. You can't really force them off per se, but it helps discharge the internal capacitance, I would guess, is how you would want to word it, which would turn the MOSFETs off. I'm probably going to regret talking this much in the morning when I wake up and review this video, but it's late and I've partied for pretty much 3 days in a row, so now we have the bridge caps here. Gate drive transformer made with a there it goes, made with a 20mm EPCOS T38 core, and then you can see the bottom there. It's the same thing as the last one was, except the last one was a little bit bigger. Here you can see this was the one that I did build originally for the coil, but I fried the MOSFETs somehow, so I think I had a huge line surge, because this house has old wiring and it surges constantly. The fridge will kick on and my lights will dim down, and then they'll like get so freaking bright for a second. It's like, I don't know, it's weird. But anyways, let's see, the power supply will plug in. This is power input, and this is the bridge output. So this here will plug in, and it is polarized with a locking ramp, so you cannot plug it in the wrong way, and it'll clip in like that, and it clicks So yeah, and then this is for the transformer, for the gate drive transformer. Probably gonna end up putting a connector on there for the driver board so I can disconnect it if need be. Trying to make everything modular so I can take it apart, work on it, fix it, whatever, upgrade it, whatever I need to do. So put that right there. And then for the driver board, kind of happy about this. Turned out pretty nicely, as you can see. Now there might be one or two people thinking about how this is going to work at such a high frequency. Questioning if it's actually going to work at a high frequency, this driver or not. You know, I don't know. I really don't know. I'm questioning it too. Actually, I'm probably the only one who's questioning it. Nobody else probably really cares too much. Here you can see my soldering job. Not really the greatest. That right there needs to be fixed because it's a little weird. But ground plane is right here. Then it shoots up one, and then it's this big blob here, and it comes up over here. And then it goes over to this regulator via a jumper wire underneath the heatsink there. You can see it right there, kind of. And then my grounds go clean down on jumper wires underneath the IC sockets. You can't really see them. Right there's one in that one, and the 16 dip one. But, so hopefully there's nothing wrong with the grounds. Hopefully they're as short as they can be, really. So hopefully they're good enough that it's not going to affect performance too much. So this 12 volt regulator, that's a 6 volt regulator, and then electrolytic caps on the UCC power rails, along with 47 microfarad tantalum caps underneath. Yeah, pretty much it's just your basic driver. It's actually Steve Ward's 0.5 dual resonant driver, so I'm just going to leave out the primary cap and keep the secondary bass feedback. So hopefully it works the way it should. So yeah, I'm pretty sure that's about it. So we have the power supply. We have the power supply, driver board, and half bridge. Yeah, I don't know. That turned out pretty well. So the only thing left to do is both interrupters, because this one is going to have two different interrupters. One is going to be for audio modulation, the other one is going to be for just a standard interrupter. The interrupter I'm using is Steve Ward's universal interrupter. It uses, the actual one uses 3 555s, but I'm leaving out the burst. The burst enable one. The one that gives gives a quick pulse or whatever to I don't know. I didn't really study the schematic too well, so I don't really know what the third one does. But these ones, one controls the frequency, the other one kind of does like a on-off thing, like controls the on-off time. So I'm hoping to get right around 10 hertz to about probably 200-300 hertz at an on time up to, I don't know, probably, an on and off time equivalent to about 20 to 30% duty cycle. So, and then the SG 3525 will just be set up to like just your basic plasma speaker, doing frequency modulation to get the audio modulation into the coil, and then it'll just be the outputs will just be controlled with this here, and the only two pots on there will be to control these, because this will have a 10K pot internally set for the best sound on the coil. So along with the best, I'll also tune up the dead time a little bit because you can choose dead time with just one resistor with this thing. So not sure exactly how well that'll work or not, but we'll figure it out. I'll figure it out as I go. I'm going to bed after this video because it's late and I'm tired. So oh, we have one more thing. This is the secondary here. It is, I can't remember if I showed this in the other video or not, but it's 1/2-inch pipe which has a 22mm outer diameter, and it's about 85 millimeters long. It'll be bound with 80 millimeters of 44 gauge wire. To give you an idea, that is 0.0635 millimeters, which is less than 2/1000ths of an inch thick. So you can kind of see it there against my hand. Not really. Let's bring it down here where you can maybe see it a little bit better. Yeah, there you go. Wrap it around this and bring it down here. There we go. There, you can see it. It's teeny tiny. I've already tried winding this thing twice. You can see there my failed attempts. So, and then this will be the primary form. It's a 33 millimeter form. This ain't the exact one, but it's the same pipe. So, yeah. And then I need votes. Acrylic or oak for the case. I can have. I know for sure that I can have the oak CNC'd out, because where I work they actually have a CNC machine. They have two of them actually, big ass industrial ones. It's awesome. So I'm pretty sure I could talk, because I actually rent from the owners of the plant. So the owners of the plant own the building that I rent from. So I'm pretty sure if I talk to them, and I could probably get it done pretty cheaply. So. Acrylic, I'd have to go online and find a place, but I'm sure it wouldn't be too much of a difference. So acrylic or oak. Kind of leaning towards, well, both actually, because they both have their benefits. Like with acrylic, I could light it up. With oak, I could stain it and make it look real nice, and I don't know, it kind of, I don't know, I'm having a tough time deciding, and since it's for my girlfriend, I don't want to ask her, because, you know, it's kind of a surprise thing. She knows that she has an idea that I'm making a Tesla coil, but she doesn't actually know what it's going to do. There are things that I'm not telling you guys either, because of the fact that I know she's going to get on here and view my videos, and then I'm going to get really pissed. But let's see. I think I'll probably wake up early, go to her house for a little bit, and then come back, and I'll work on the interrupter, make a video of the prototype on the breadboard, tweak it a little bit, and I've got iMovie now, so I can cut and edit that, and I can do different mods on that, and I can keep it all in one video. So until then, peace out, guys. See you in the next video, and don't forget to comment with your opinion on oak or acrylic, because I'm really having a tough time deciding, and you guys are my last hope, so please don't let me down. So once again, peace out, and I'll see you in the next video.